You're walking down a quiet street at night. Nothing is there, no footsteps, no shadows, and yet your heart is pounding. Your palms are damp. Every muscle is coiled, ready to run. But the real answer for why this happens is far stranger than you think. Your brain is not built for the world you live in. It's still running software from a world that stopped existing 10,000 years ago, a world of teeth, claws, and things that moved in tall grass, a world where the cost of ignoring a threat was your life. And the system that kept your ancestors alive is still online right now, still scanning, still armed, even when there's nothing left to hunt you. Deep inside your skull, tucked beneath the folds of your cortex, sits a small almond-shaped structure called the amygdala. It's tiny, barely the size of a peanut, but it has one job, and it does that job faster than any other part of your brain. It decides in a fraction of a second whether something is dangerous before you've even consciously seen it. Neuroscientist Joseph Ledoux spent decades mapping exactly how this happens. He discovered something unsettling. There are two pathways information can take when it enters your brain. One is slow. It runs through your visual cortex, gets analyzed, gets understood, and then gets passed along as a conscious thought. That pathway takes time. The other pathway is fast. Ledoux called it the low road. It skips the thinking part entirely and goes straight from your eyes to your amygdala. You react before you even know what you're reacting to. That's why you flinch at a shape in the grass before you register it's just a stick. That's why a loud bang makes you duck before you decide it was a car backfiring. Your body already moved. Your mind is just catching up. This isn't a flaw, it's a feature, and it's ancient. Psychologist Arne Ullman ran a series of experiments in the 1990s that revealed just how deep this wiring goes. He showed people photographs mixed into a grid of images, flashed for a fraction of a second. Some photos were neutral, flowers, mushrooms, ordinary things. Others contained snakes or spiders. Uman found that people located the snake or spider almost instantly, faster than they could find a flower in the same grid, even when the flower was just as visually distinct. Your brain isn't just good at spotting danger, it's specifically tuned to spot the kinds of danger your ancestors actually faced. Here's what makes it stranger. Uman's team ran the test again, but this time they used images of modern threats instead. Guns, frayed electrical wires, speeding cars, the exact things statistically far more likely to kill you today than a snake ever will. And the brain didn't respond the same way. No shortcut, no fast lane, just the slow road like anything else. Guns have existed for centuries, cars for barely 100 years. In evolutionary time, that's nothing. Blink. Your threat detection system hasn't caught up because it can't. It wasn't built to update that fast. It was built once over millions of years by whatever kept your ancestors alive long enough to have children. And nothing about a car has ever been around long enough to leave a mark on that code. So think about what that means for you right now in a century full of dangers evolution never prepared you for. Your amygdala doesn't know the difference between a predator in the dark and a difficult email sitting in your inbox. It doesn't know the difference between a lion in the grass and your phone buzzing with a message from your boss at 11 p.m. To the oldest part of your brain, a threat is a threat, and it responds the same way it always has. Heart rate spikes, muscles tighten, digestion slows, blood moves toward your limbs, away from your stomach, because your ancestors needed to run, not digest lunch. Neuroendocrinologist Robert Sapolsky spent years studying this exact mismatch, largely by watching baboons in Kenya. He noticed something the baboons made obvious. In the wild, stress is supposed to be short. A predator appears, your body mobilizes everything it has, you survive or you don't, and then it's over. The stress response shuts off. But humans, Sapolsky pointed out, have a strange and unique ability. We can turn on that same full-body alarm system just by thinking about something, a memory, a worry, a meeting 3 days from now. We can trigger the exact biology built for a lion using nothing but a thought. And unlike a lion, a thought doesn't go away when you run from it. That's the part that should genuinely unsettle you. Your ancestors' stress had an ending. Yours often doesn't. The chemical flood that was supposed to last minutes can now stretch across weeks, months if you let it. There's a name for this mismatch. Evolutionary psychologist Randolph Ness calls it the smoke detector principle. A smoke detector is designed to go off too easily. It'll scream over burnt toast.